All right. Another exam question that we are given in this platform on our Euclidean geometry. This is very, very important for us to just understand some basic things here. That was question number 5. All right. The first part of our question, which is 5.1, was to name two properties of a rhombus. Remember, I told you these properties of the shapes on each and every part on the introduction. And you're supposed to know this. And I say that the rhombus, the rectangle, the square, they are taken from a parallelogram, their properties. So they have the properties of a parallelogram. But they are just going to have some a little bit differences that we have between these rhombus, rectangle, and a square. So what is it that we have on a rhombus? The first thing from the property that it has the properties of a parallelogram. So you must consider two pairs of opposite sides being parallel. All right. So you can consider two pairs, or let us just say both. Okay, let us just write this in a good way, guys. All right, both pairs. All right, they have got both pairs of opposite sides equal. All right, parallel. Sorry, parallel. The major property there is being parallel, because we are referring that a rhombus is simply what? Is simply a parallelogram. That's what we. But the difference that we're going to have is that these sides, yes, they are parallel, but all the sides will be equal. All right, that is the difference that we have now, but it is actually a parallelogram. All right, so the difference will be that all sides are equal. All sides are equal, which is something that we have also on a square. Remember, on a square, all sides are equal also on a square. So these are properties that are major, common to each other. So it does not limit you to list them. All right. Remember what happens on the diagonals. The diagonals of a rhombus, they bisect at 90 degrees. So diagonals, they do bisect. That is the major thing. Diagonals bisect at right angles. That is at 90 degrees at right angles. What does it mean? These diagonals that we see, they do bisect each other. That is, this is divided into two equal parts, but not just divided into two equal parts, at 90 degrees. At 90 degrees, it must be at 90 degrees. So there are so many properties. Also, these diagonals, they do bisect these angles here. They are being bisected into two equal parts. So the same diagonals that bisect each other, they do bisect the angles also. So the diagonals, these are diagonals, sorry. All right, diagonals, they do bisect the angles. All right, that is the angles, the apex, these angles, they're being divided into two equal parts. Okay, then also both pairs of opposite angles are equal, just like a parallelogram. These opposite angles are equal, right? So you can consider that. So these are the properties of rhombus, so many. So you can consider that both pairs. So here we've got both pairs of opposite angles are equal. All right, we are talking about angles being equal, opposite angles, which is the major property of a parallelogram. Which is the major part that we have on a parallelogram. Being opposite sides being parallel and having opposite angles being equal. But for it now to differentiate on a rhombus, we shall have all sides being equal. So like I said, a rhombus, it takes the properties of a what? Of a parallelogram. It is simply a parallelogram with equal sides. That's in short. In short, this is a parallelogram. A parallelogram with equal sides. With equal sides. So if it is a parallelogram with equal sides, and you know the properties of a parallelogram, therefore list all those properties, okay? That's it, guys. 5.2, the diagram below shows a parallelogram. Now we are back to that parallelogram, and this is what we are used to. You know that a parallelogram, these opposite sides are parallel, not just parallel, but they are parallel and equal, which is the same thing on this side. They're parallel and equal. We know that opposite angles of a parallelogram, they are equal. The angle at A is equal to the angle at C. These are properties. You are using the properties. So that's why I say, guys, you need the properties at heart. You need to know the properties at heart. So anyways, determine the value of angle C. So angle C is equal to 2x minus 60. So in order for us to determine or to have the angle C, we must have the value of x. And to have the value of x, there's no way we are going to use the concept that these angles are equal. We formulate an equation from the opposite angles, which are equal. Remember that angle A is equal to angle C. This is the major property of a what? Of a parallelogram, opposite angles. Equal. All right? So opposite angles are equal. So if that is the case, we are going to formulate an equation. By formulating the equation, x plus 20 degrees is equal to angle C, which is 2x minus 60 degrees. We have formulated an equation where we can solve for x. By solving for x, we can be able to find angle C because we just have to substitute the value of x. So where are we going to have the value of x? We have to solve the equation. This is now an equation. The left-hand side is equal to the right-hand side. So you're supposed to solve for x first. All right, so find the value of x. How can we do that? By collecting the terms. You can collect the terms of x to one side of the equation. X goes this side, this 2x goes to this side where there is x. So it is going to be x. If we take this x, if the moment it jumps the equal sign, the moment it jumps this equal sign, it changes its sign. So here it's a positive. The sign is not indicated, it's a positive. So once it jumps this side, it becomes a negative. So it will be minus 2x is equal to, all right, already on this side, there is a minus 60 degrees there. So you're going to have a minus 60 degrees. We transpose our 20 degrees, which was on the left side, across the equal side, that side. So it was a plus 20 degrees. The moment it jumps the equal sign, because there's an equal sign, it crosses the equal sign, it changes the sign. So it's going to be a negative 20. It was a positive. So on the other side, it will be a minus 20. So that's it. So x minus 2x, this is the same as 1. So that's 1 minus 2, which is minus 1x. So it's same as minus x, right? Minus 20 minus 60 minus 20, which is actually minus 80, right? So this is minus 80 degrees, or you can just use your calculator, guys. Like I always say, that the calculator is always there to assist you in exam. The first thing, it was 1 minus 2. That's 1 minus 2, which is minus 1. Then minus 60 minus 20. That's minus 60 minus 20. Like this, which will be minus 80. So to find x, you're going to divide by -1 by -1 so that this cancels. X will be positive 80, but x is not our question. The question is not asking us to calculate the value of x. If it was to calculate the value of x, they were going to state calculate the value of x. But there is no way that you can have the value or the size of angle C, the one that we are given on our question. There's no way we can determine the angle C without the value of x, because angle C is created or is made of x. This is our angle C. Angle C is given by the expression 2x minus 60 degrees. So in order for us to have that angle C now, we just have to substitute the value of x that we determined. So it is going to be 2 times x, of which our x, we got 80 degrees, minus 60. So that will be angle C. So 2 times 80 is something like 160 there. 160 degrees minus 60 degrees, which is something like 100 degrees. So it means this angle here is supposed to be 100 degrees. And also this angle here is supposed to be 100. Remember, opposite angles of this parallelogram, of a parallelogram, they are equal. So it was another way that we could have actually solved it or proved with it, like to just use this part, x, just substitute 80 plus 20, that's 100, remember, or x there is 8. So that is how we can solve for these typical questions. They need you to understand the properties. They know that some of us, when it comes to these properties, we simply take it lightly and just leave it like that. We do not want to study the properties of the shapes. Know the properties of each and every shape. There you are given it's a parallelogram. That is why we have to take angle A to be equal to angle C, because we know that on a parallelogram, the opposite angles are equal. The two pairs of opposite sides equal and parallel. Opposite angles equals. Diagonals do bisect. These are properties of the shape. So you need to know the properties of each and every shape.